दिल्ली माउड़ा रे गुलाल गुलाबी रंग केसरिया।
In this class we will solve exercise 8.2 and question number 5. It is one of the best question. Why? Actually, from class 3rd or 4th we get to know how to find the midpoint of any line, means to divide any line segment in two parts. So two parts means take more than half distance, and this, and you will join, this will be the midpoint. But it's very hard if you have given a line segment and you have to cut it in 3 equal parts. Actually it was 2 parts, and then you have to set 4 parts. So again you have to take midpoint of this, midpoint of this. So in class 6 this type of question was there, find in 2 part and then 4 part. But here we are getting line segment in 3 equal part, 3 equal part without measurement, only with the help of geometry. And this is the BD as a diagonal, but we will cut it in 3 equal part. So the question is different, actually you have been given the diagonals and you have to divide in 3 equal part. So around it you will make a parallelogram there, and then it is possible to do it. So that is the theorem, that is the question here, question number 5. In a parallelogram ABCD, this ABCD, E and F are, this is E and this is F, are midpoints of side AB and CD respectively, so that the line segment AF, this AF, I will join it, AF and EC trisect this line segment. So with the help of this background, it's very amazing to check it. 3 part. 3 means you can divide it 6 part also. So 2 and 3. So you have got 2, 3, 4, 4. This is 4. Actually it was 2, then 3, then 4. Remains to 5. How can we divide any line segment in 5 equal part? So that will be taught in class 10th. 5, 6, any part you can draw. Okay, so this is the 3 part. So now come, actually I have drawn this figure with actual, this is my actual parallelogram, this one. Means practical also do, practical. This is A, B, C and D, this is the midpoint. And I will measure these are equal or not. Okay, so divide it, first join. So you will see all the theorems will be applied here, very cleverly you have to apply it. This. Yes, even if I have drawn rough figure, then in spite of it, this appears to be parallel to this, In the question it is not given, this is parallel, means AF parallel to EC, it is not given. But we will prove it, that it is. How? This is the good thing. Okay, so first of all it was given, what is given, it is written, so you may write some points only. So write the given point. Given ABCD is a parallelogram. Parallel and gram. And E and F are midpoint. E and F are midpoints. That's enough. And rest everything is visible in the figure. And you have to prove this diagonals bisected, trisected. And the points are given here P and Q. This is point given P and this is given Q. So appears to be some complicated figure, but it's not so much complicated. So first of all, we will prove, this line is AF is parallel to EC. How will you prove it? Okay. Earlier it is said ABCD is a parallelogram. Yes, so this line is parallel to this because it's a parallelogram. So AB parallel to DC. So also AE parallel to FC. Okay. It is said this is the midpoint, means parallel, so equal length, half of length also equal. So this equal to this. Parallel and equal. So this is the one pair parallel and the one same pair equal. With the help of this 8.18, it's very important here. So this is the parallel and the same thing is equal, half of. So parallel and same pair equal. So this is AECF will be a parallelogram. Parallelogram means this line will be parallel to this, and then we will apply midpoint theorem. Midpoint theorem in this triangle, this triangle. So we will prove it this equal to this, and the same we will apply from here, and we will prove BQ equal to PQ. So PQ is common, so that's why all the three things will be equal. So that's an proof. So slowly I will write and I will tell. So keep patience and write in your copy. So this is the given. So first prove this is AECF is a parallelogram. This line is parallel. So write AE parallel to FC. AE parallel to FC. Why? As ABCD is a parallelogram. So parallelogram means opposite sides are parallel. So I have not taken AB, I have taken AE. So this is also parallel. Okay. Then AE is equal to FC. AE equals to FC as AB equals to DC, because these are the opposite side of a parallelogram, and AB upon 2E will be equal to DC upon 2. AB upon 2, DC upon 2, and AB upon 2 is AE, DC upon 2 is DC, because this is the midpoint now. So FC. So including these two, having these two, AE parallel and AE equal, theorem 8.8, one pair parallel and the same pair equal. So triangle AECF is a parallelogram. Why? Theorem 8.8. You will not write 8.8, you will write the full full statement, so that will be much better. Theorem in a triangle, in a quadrilateral, if one opposite pair parallel, one opposite pair of side parallel, you can write like this, and same pair equal. Pair means pair of sides, and same pair equal, then Then the quadrilateral is parallelogram. Then quadrilateral is parallelogram. Again, because quadrilateral parallelogram has two conditions, na? So this is 1 and 1. In detail, I have told in many all the videos. 2 required 2. So this is to 2 and extra 3 we will be given. Okay. So AEFC, AECF. Yes, AECF. So sequence should be maintained. Okay. So it's a parallelogram means this is parallel to EC. We know this parallel, but AF parallel to EC. So hence AF parallel to EC. This. Then now the question is easy. I will erase this. This is also. Actually, we have a target to prove this. We have done it. Then the question is proof. When you draw this DB. So DB is trisected by these parallel lines. And for these provements is very easy, midpoint theorem. We will use midpoint theorem. For that, okay, so you take, suppose after some for the some time is this line is not made here and this is not also made here. So what you are getting? Two triangles. This one triangle D. Okay, what does it mean? Its name? Its name is P and Q. So this is P and this is Q. So two triangles, one triangles. Let me identify blue color here. This one. This one. I am setting here, but you will only move your eyes. And another one is red. This. So first come on for this triangle. So this triangle, this side is parallel. If AF parallel to EC means PF parallel to QC. If this is happening, so now in triangle, and this is the midpoint. Midpoint F is midpoint, and this line is parallel to this. So midpoint theorem 8.10. Okay, so come on this. So you can write just after this AF parallel to, so just after this in triangle. Okay, you may write here PF. So PF also parallel to QC. Yes, this is the required thing. This. Now, in triangle DCQ, whenever this type of many points are there, D, C or Q, so we should to start alphabetical order. So we will write C, D and Q in triangle C, D. C first, then D. So it's an only it's my method to write in a triangle C, D, Q. So in triangle C, D, Q, what is happening here? F is the midpoint and this line is parallel to this. F is midpoint. F is midpoint of DC and and PF, it is already written here, PF parallel to QC. So one midpoint and one parallel line. So you will get this is also midpoint. So so DP, P is also midpoint of DQ. So DP is equal to PQ, and this you have written by theorem, yes, inverse of midpoint theorem, by theorem 8.10, by theorem 8.10. So it's not a good practice to write 8.10. You should write the inverse theorem of midpoint theorem, inverse of midpoint theorem. Okay, like this, because I don't have a space, all the theorems are written here, otherwise it will be in a line. So dP is equal to PQ is very important, this one. So this I have made now. Similarly, I am using this red here only for you will move your eyesight here, eyesight, this, and you can see, okay, let me say it like this, yes. So in this triangle, in triangle A, B and P, it is confirmed E is the midpoint, and this line AP parallel to EQ, because okay, PF just like V hai na, PF QC, similarly AP is parallel to EQ because it is here. Okay, so now write, now in triangle, or you may, you can write the just result similarly, just write similarly is also technique. Similarly, this PQ, na? So BQ is equal to QP or PQ, QB or BQ, PQ is equal to QB. First write it is, yes, PQ is equal to QB. Why have you written similar to it? So you will explain this one by writing. So all the theorems are used very, accurately. You should write, equations number, results number in everywhere. Okay, why this is happening? As whatever I've written in this here, I'm writing an explanation. As in triangle ABP, AP parallel to EQ, AP parallel to EQ, and E is midpoint of AB. So inverse theorem of midpoint, inverse of midpoint theorem. So you have explained here. Actually, this is theorem 10.10. You can write 10.10, theorem 8.10. This is 8.10. And now come PQ. PQ is common here. So all the three will be equal. So comparing these two, above two equations, dp is equal to pq is equal to qb, dp is equal to pq is equal to qb, this, and hence this equal to this equal to this, so hence db is trisected by these lines, hence db is trisected, and right here proved. So this was the question. I hope you have enjoyed. So keep watching. Thank you.